All right,
Recording in
welcome back
progress.
to our practice in converting from one concentration unit to another. We have looked at converting mass volume percent units to molarity and molality. And now in this part of this problem, we are asked to convert to mole fraction. So again, let's kind of remind ourselves of the assumption and definitions that we're working with here. So mole fraction, Greek letter chi, is equal to moles solute over total moles of solution, which means this is moles solute over moles solute and moles solvent. Of course, my dog decides to bark right now. Okay, so again, chemists are cheap and lazy. Let's go back and see if we have some idea about the moles of solute and maybe something about the solvent. So from our prior calculations, so from previous calculations where we assumed 1,000 grams of solution, we knew that we had 0.154 moles of sodium chloride in that 1,000 grams of solution. So we already know a big bulk of what's needed to calculate mole fraction, right? We know the moles of solute, which leaves us with moles solvent. So let's see if maybe we had something relating to the solvent that we calculated. If we're talking about solvent, my brain thinks molality, right? So let's look at our molality conversions. Yeah, okay, so here, molality problem, we had a mass of water in kilograms. And if I'm thinking about trying to get to moles, I know that I'm going to need to do a molar mass conversion here. So going back, let's take this mass, which is our kilograms expressed as grams, so 995.6 grams of solvent, and recycle it here. So we had 0.99, nope, that's the kilograms, 996 point, nope, 5.6 grams of our solvent, H2O. And because I want moles, I better get this into moles by dividing by molar mass. So 1 mole of water weighs 18.02 grams. This was given to me in the body of the problem. So if I go kind of looking back, all right, I was given the density of the solution, molar mass of the solute, and molar mass of the solvent. So I'm utilizing my molar mass of solvent. So let's take our 995.6 and divide by 18.02. This is 55.2497 moles of H2O. So let's see if we can't maybe combine moles, solute, and solvent to get total moles. So I will do like a color combo, right? Red and blue make purple. So then total moles of solution is going to be our 0.15400 moles of saline, sodium chloride, the solute, plus 55.2497 moles H2O. So let's see here, plus 0.154 gives me 55.4, and I'm going to be limited here to that sig fig. So we'll do 55.404, keeping a couple digits that are non-significant to avoid rounding error. So 55.404 moles of solution in total, which means that our mole fraction is going to be our moles of solute, 0.15400 moles of solute over the total moles of solution, 55.404 moles of solution. So I'm going to divide and check this for yourself, but I get a mole fraction of 0.00279, or rounding to the correct sig figs, this would be 280. And mole fractions, notice it's mole over mole, are dimensionless. So this would be our answer. This would be our result. And a good thing to ask yourself when you're doing these mole conversions is, do I get something that makes sense, right? So let's look at our 0.9 mass volume percent, right? That is not even a whole percentage, right? We are barely 1% mass of NaCl in this whole liter of solution. So if you imagine like all my moles of water present in here, all my moles of water present in here, and knowing that like a couple of those moles are NaCl, we would expect the fraction to be very, very small. So like this value makes sense to me. Like, yeah, it's a really small fraction, but expresses a mole percent. That'd be 0.28 or 0.3% moles, not mass. So this seems to be in the realm of like, we're doing things okay. So this is how we would do mole fraction. So we don't need any more space. Our last conversion, which we'll do in our next video because my iPad's gonna die, is parts per million. So we'll utilize our definition of parts per million to convert from a mass volume percent to parts per million. And ideally, we'll just be recycling some of the same extensive properties we've calculated to get this definition. So I'll see you in our next video.